Polynomials, remainder, and factor theorem. I will consider dividing polynomials. We'll look at long division, and then we will consider synthetic division. And then there's, I believe it's just one problem that deals with the so-called remainder theorem. I won't spend time on the factor theorem. The factor theorem simply says that any polynomial of nth degree, you ought to be able to factor it n times. And you get that idea. You've been doing that already. Say, for example, f of x equals to, let's say, x squared minus 9. So here, n is equal to 2. So the factor theorem says that we should be able to factor this at most twice. Well, we can. X minus 3 times the expression x plus 3. So have not you been doing that like all your life? Right. So you've been making use of the factor theorem and probably didn't know that that's what they called it, but that's all that is. Even if the roots are imaginary, watch how I just change that problem up. Just put a plus there, plus 9 instead of a minus 9. Well, the factors here would be x plus 3i times x minus 3i. You remember from this one we get x squared is equal to negative 9. Take the square root of both sides. X is equal to plus or minus I times square root of 9, which is just plus or minus 3i. So that's all the factor theorem says, I think, in a nutshell. So no need to labor with that. Let's look at long division. Long division for algebra, if you remember, dividing some polynomial by let's say a binomial. Binomial means 2, right? Poly means many crackers, poly means many, right? So so we have a polynomial divided by a binomial, typically is what you would see in algebra. That whole scheme is based on dividing a number by another number. It's the same schematic flow. So the key is making sure that we understand how to divide numbers. That's the essential. We use that same exact process to divide polynomials, right? So you remember this, right? You got like 26 divided into 3,983, right? Okay. So that's dividing numbers. You're going to keep that in your head when we talk about dividing polynomials. And so that's just that problem just finished. And then the way you write the answer. So if 26 goes into 3,983 153 times with the remainder of 5, and you remember you would write it like that. Now check this out. This is the same. This is the same as saying 153 plus 5 over 26. That's the same thing as saying 153 526. Okay. You'll see the plus or the minus sign with the algebraic expressions. Right? You don't see it with just the numbers here, but we see it with algebra. So algebra highlights the sign in between the whole term, where they talk about this terminology, divisor, quotient. It just separates the whole term from the remainder. Right. Okay. So now dividing a polynomial. On the left side is the dividing by long division. Then on the right side is synthetic division. Let's hold off on synthetic division. Bless you. And let's just focus on the long division. So here I have a polynomial which is this x to the third plus 4x squared minus 5x plus 5. That's to be divided by x minus 3. Now, for all the terms here and also the terms there, we want to list them in descending order with respect to the powers, right? So notice here the power goes from second power, first power. This is ideally, you don't see it, this is x to the 0. Because x to the 0 is equal to 1. So you don't see that, but just want to show you the descending order. And likewise, even here, this is x to the first power, and then minus that constant. If you're given a problem, if it's not in order, you have to write the terms in order, in descending order, to divide. That's important. Okay? If the polynomial is missing some terms in between, say for example, if we have 5x to the fourth minus 12x to the second plus 7x minus 51, and this is said to be divided by, let's say, 2x minus 3. Look at that polynomial. I'm missing a term. I'm missing the x to the third, right? So if we're missing a term, you want to insert a 0. So insert zero for missing terms. So for example, if we are missing an x to the third term, you want to insert here 0 times x to the third. So just saying insert a 0, you know, just off the cuff, you're thinking, oh, just put a 0 there. We're not saying just put a 0. We're saying put a 0 that represents that pivot position. So that position there that we're missing is, for this particular example, x to the third. And you know that 0 times anything is 0 anyway. But 0 times x to the third is going to hold a pivot position, because here's the neat thing. I had Bible study last night online with our young adults, and one of the young ladies in our church, she lives in Nashville. She's a software engineer. So she and I were kind of kicking it about some of the stuff that she studied back in school. What did she learn to get her to where she is there? And and she was saying that most of the codes that she writes for this company up in Nashville, it's a lot of Java scripts. But she said a lot of times you work for these companies and they hire you as a software engineer, you may have to start writing codes for program language that maybe you didn't study before. But she said there's no problem. If you know how to do coding and you've learned that from maybe other programs, it's easy to adapt to a different program to be able to write those codes. And so she and I were talking about, you know, some of the embedded nature in those codes that's really universal. And she said, you know, it's nothing but math. I said, yeah, I know. I said, my minor was computer programming, and it was very neat seeing the connection with computer science and also the mathematics. So the reason why I'm telling you that is this. To divide by long division here is mechanical. That is, it's a process where the process is saying, if it's x to the fourth power, like for my example there, for that first term, the process says I need to be able to see then an x to the third. I need to be able to see x to the second. I need to be able to see x to the first. need to be able to see a constant. If it's not, then you have to insert it. Why is that significant? It's significant for the process, but it's easy for those who program in computer science because the program is based on that same process. If n is equal to whatever number that's assigned to it, then the do loop says, now consider n minus 1. And then it says, it has this term, generic term for that term that you're to divide by the binomial, like here, like the 2x minus 3. So it's going to put that information there, but it has to see that next position. If it doesn't see the computer itself, it says that if no n minus 1 term exists, insert, and we have these neat codes in C++, insert then the 0. It will insert 0x to the third. It will insert those zeros. It needs to see that. So the computer programming mechanism is based on, watch this, how the human mind processed things. Because it was a human that programmed. And the human that programmed the division for, if it's a calculator or your computer, is based on the same process right here. The computer language, if you break it down and look at those statements, this is all they're doing. So if we're missing a 0, insert a 0. And maybe we'll have an example later on that I can definitely show you. So for this problem, so this would imply then that this would be 5x to the 4th plus 0x to the 3rd minus 12x squared plus 7x minus 51. That would be needed for long division. It is also the same idea for synthetic division. Let's look at this example here. So we're going to divide this x to the 3rd plus 4x squared minus 5x plus 5 by x minus 3. So we're going to write the terms in descending order, insert zeros. We don't have any zeros here, so nothing to insert. So the same thing for the regular numbers in division. I'm going to take this first term here and divide it by this term here. So I'm going to say x to the 3rd divided by x. That gives me x squared. Right? So the x squared goes there. Isn't that like very similar to how we would divide numbers, right? Take the first number, the first digit, or the first two digits, and the big term that we're dividing into, and then we divide that by a lot of times it's just a monomial. So then the second thing we do is to take this x to the 2nd and multiply it times x minus 3. Again, that's the same process in terms of how we would divide numbers. So it's x. Let's get this other stuff out the way. So it's x times x squared is x to the 3rd. X squared times minus 3 is minus 3 x squared. Remember, you draw your line and we subtract. So we put the negative here. And then here, this is already negative, so if I'm negating that, it becomes a plus, right? Negative times a negative is a positive. So the sign that we use is the sign that we've circled there. So then we have x squared minus x squared, that goes out. 4x squared, this is plus 3x squared, is 7x squared. Do the process back over again. Now I'm going to divide 7x squared by the first term here, by x. That gives me 7x. The 7x goes there, right? Again, isn't that process the same in terms of dividing numbers? It's based on that. Do the process back over. 7x times x minus 3 goes here. 7x times x is 7x squared. 7x times minus 3 is minus 21x. Draw your line, subtract. So we subtract on that 21x is already negative, so it becomes positive. Then we add the terms up and down. So whatever the sign is. So it's 7x squared minus 7x squared cancels out. Minus 5x plus 21x is 16x. Always bring down the next term, right? Always drop that next term. When we did here the the subtraction and the addition, we bring down the next term. But that's the same process for numbers as well. And then step 3, 16x divided by this first term again by x is 16. We put the 16 up in the quotient part. Then we say 16 times x. We get 16x. 16 times minus 3 is minus 48. Draw a line. Subtract. Subtract. That becomes plus. Add up. And then the remainder is the remainder if its degree is less than the degree of the binomial. This is the binomial. So I stop the process if the degree of the remainder, this is 0, x to the 0 is just a constant, that degree is less than the degree of here, the so-called binomial, right? X to the first. So let's focus on that, then we'll come back to synthetic division. So let's do some problems. Well, I have this in the notes. I suppose I need to talk about it here, and then we'll look at some problems. What synthetic division does, it's the shortcut to long division. It's just the shortcut, and by the shortcut we mean that if I'm dividing by x minus 3 for synthetic division, we're going to use x equal to 3. And basically all they've done was say x minus 3 equal to 0, and we get x equal to 3, and that 3 goes there. See the terms over here, the 1, the 4, the minus 5, and the 5? Well, they come from the coefficients of the term that I'm divided into. This is 1, 4, negative 5, and 5. You just list them here. It's a shortcut. Here's how it goes. You're going to always bring down that first term there, automatically, whatever it is. Then you're going to multiply the 3 times the 1. We get 3. You're going to add these two numbers here. Whatever the sign is, that's what you operate with. So 4 plus 3 is 7. And then we multiply 3 times 7, you get 21. We add these two terms, right? 21 minus 5, we get 16. Multiply 3 times 16, you get 48. 5 plus 48 is 53. That's your remainder. Now look at the terms that you have here, 1, 7, and 16. Those are the coefficients of the answer. But these coefficients are matched with whatever the degree was in the beginning. If it was 3, then for synthetic division, this is going to be n minus 1. So my power would be 2. So I'll start with, it's just 1 times x to the second plus 7x plus 16, then plus the remainder, 53 over that binomial, x minus 3. So you get the same thing with long division or synthetic division. Synthetic division is just the shortcut. So, but let's work some problems and kind of get our hands dirty. Right. This is just explanation of that. Synthetic division, put that in there. You can read over that. Just goes through the steps. We're going to just look at some problems and try to repeat all this information. But here are the steps if you need to see them. Then the remainder theorem, and I'll talk about that given a problem. Let's just, here's the thing, folks. This is a math class. Let's do math. So here we're dividing this x minus 1 into x to the third plus 3x squared minus 6x plus 2. They're already listed in descending order, so I don't have to reorder anything. And then there's no missing terms. If there's an x to the third, there's an x squared, there's an x, right? There's a constant. So we divide, so we say x minus 1 is divided into this x to the third plus 3x squared minus 6x plus 2. So the first thing we do is we're going to divide that x to the third by x, the first step. Right? So when we do that, we get x to the second. So I put the x to the second, and I just write it right up top. It's fine. X to the second. Then I'm going to multiply x to the second times this x minus 1. So x to the second times x is x to the third. X to the second times negative 1 is minus x squared. Draw my line, subtract. So this becomes negative. I just changed those dang on signs. So this becomes negative, that becomes positive. That's all that means. Okay? Because writing those signs in a circle, that just confuses the heck out of me when I go back and look at it. I'm like, so which sign is it for real? Yes, Emmanuel?
Why did the signs change again?
Okay. Again, the process is based on dividing numbers. You got 5 divided into, let's say 16. You say 5 goes into 16 3 times, right? Yeah. 5 times 3 is 15. What do? You subtract, right? The signs change. Again, this process is based on the arithmetic. It's the same process. Nothing has changed. So again, I mean, in your head, you're just saying, look, I'm just dividing numbers. That's all you're doing. It's the same exact process, right? Bring down the 1. If there was another number over here, you know, like whatever, 3, you know, you bring that down, whatever. So that's all we're doing. Yep. Good deal. Good deal. So we draw a line, subtract. So this cancels out. And here we're adding those two. That's 4x squared. Bring down the next term, minus 6x. The next thing we divide is that 4x squared is being divided by x. It's being divided always by the first term here. So this is 4x. It's positive, so you write plus 4x. So then I multiply 4x times that binomial. So 4x times x is 4x squared. 4x times 1 is minus 4x. Draw a line and subtract. Becomes negative. Negative times negative is positive. Well, 4x squared minus 4x squared cancels out. Here, this is negative 2x. Bring down that last term, plus 2. So there, I divide the negative 2x by x. I get negative 2. I put the negative 2 here. Right? Negative 2 times x is negative 2x. Negative 2 times negative 1 is plus 2. Draw my line. Subtract. That becomes plus. This becomes minus. Add these. Remainder 0. So here, what goes in there is the x squared plus 4x minus 2. And here, what goes here is 0, because my remainder there was 0. Okay? Is it okay? Okay. All right, let's look at the next one. All right. So we're going to divide this one. So we have 3x minus 1 divided into 9x to the third. They're all in descending order, so that's good. There's no missing terms. All right. So first step, we divide that 9x to the third divided by 3x. That gives us 3x squared. So put 3x squared up here. Multiply the 3x squared times the 3x. we get 9x to the third. Multiply the 3x squared times the minus 1. We get minus 3x squared. Draw a line, subtract, becomes negative, becomes plus. Cancels out. Add these two, we get 27x squared. Bring down the next term. So now we're going to divide this term by the first term of the binomial. So we say 27x squared divided by 3x. So this is 9x, and it's plus, so we say plus 9x up top. So 9x times 3x is 27x squared. 9x minus 1 is minus 9x. Draw a line, subtract. This becomes negative, that becomes plus. These guys cancel out. Here we add, we get 18x, bring down the minus 6. All right. We keep on dividing because 18x can be divided by 3x. Right? 18x can be divided by the 3x. So 18x over 3x. It's just 6. It's plus 6. So we say plus 6 up top. So 6 times 3x is 18x. 6 times minus 1 is minus 6. Draw a line. Subtract. This becomes negative. That becomes plus. Here, remainder 0. So that remainder, that goes there, and then the term that goes inside this box would be the 3x squared plus 9x plus 6. Well, let's see if we can work somewhere we get a remainder that's not 0, right? Remainder 0 is the perfect world. Let's see what happens to this one. So x plus 2 divided into, again, all the terms are listed in descending order. So this is 3x to the third. There's no missing terms. Plus 10x squared plus 16x minus 18. So step 1, we divide 3x to the third by x. We get 3x squared. I put the 3x squared up here. 3x squared times x is 3x to the third. 3x squared times 2 is plus 6x squared. Draw a line, subtract. That becomes negative. This becomes negative. Right? First terms always cancel out. That's the setup. And then this is 4x squared. Bring down the plus 16x. So now I'm going to divide that 4x squared by x. This is 4x. So it's plus, so we say plus 4x. 4x times x, 4x squared, 4x times 2 is plus 8x. Draw a line, subtract, becomes negative. Negative, we add up, we get 8x, and then we bring down the minus 18. And we can divide the 8x by x. That's still divisible. So 8x divided by x is 8. It's plus, so we say plus 8. So we get 8 times x is 8x. 8 times 2 is plus 16. Draw a line and subtract. This becomes negative. That becomes negative. So this cancels out, and this is negative 34. So negative 34 is our remainder. So the negative 34 will go here, and then the term that goes there is at 3x squared plus 4x plus 8. So looking at those three examples, what is something that you just kind of picked up on based on those three problems that we just got through doing? Sir? Sir?
It's basically
Well, yeah. Yeah. Simple steps, yeah. Anything else? It's not a deep question.
When you go to subtract, you just basically flip the signs.
Yes, yep, that's true. That's a good observation too. Yeah. Anything else that you noticed? What about, we did the same thing. How about that? Look. You know, ever been like in a physics class where they're talking about all this technical stuff, but the answer is like something easy, like, you know, you want a circle, so the force of that unit is 0. You know, there's no energy anymore, right? Because everything is conserved. So you know, we're talking all these technical terms, and typically the answer is very easy. Anyway. So this one is by synthetic division. So what you want to notice here are the coefficients, the 3, the 4, the -9. Let me highlight those. So all we use are just the numbers. Now for this one, for x plus 5, you want to pull out from there x equal to -5. It's not right. Keep hitting, thinking I'm hitting the pen. Got it. We're going to use x equal to -5 for synthetic division. So you're going to write -5 here, draw a line that way, and then we're going to list the coefficients of that polynomial, 3, 4, and -9. Draw a line there. Always bring down this first term, the 3. Always bring that down. The process for all of them are all the same. So always bring down that number automatically. So bring down the 3. Want to multiply the -3 times the 5, the -5 times the 3. And you put that result here at -15. Then for up and down, we always add, subtract whatever the signs are. And then when I go from this term, that -5 term, it's always being multiplied by whatever's downstairs below. So here this is -11, and so now -5 times -11 is 55. And then here we add -9 plus 55, and that just gives us, what is that? 46. Okay. That 46 is our remainder. So what I have, notice that we started with x to the second, so our answer here is going to be 1 degree less. So this is 3x minus 11 plus 46 over the binomial x plus 5. Synthetic division saves on a whole lot of steps. Yes, sir.
So on the test, will we get to pick one or the other, or are we going to?
No, it's going to say it. It'll say, yeah, it'll say work this problem by long division. Then the next problem, it'll say work this problem by synthetic division. But here's what I would do if I were you. If you're working by long division, check with synthetic division, you know, and then vice versa. You got a real good checking mechanism. You can work one that is being required, but then you can work it the other way just to check to make sure that you got it right. Yeah. So here, you're going to write that in 3x minus 11 plus 46 over x plus 5. And I think I put a comment on the next page because here it just has one box. Let me see if I did. Yeah. The answer box is not broken up into two boxes like for the previous problems. When you get into My Math Lab, you'll see that. So, but don't be alarmed if they give you one box. You can still write this whole term out right here. You can still write it out there in My Math Lab, okay? Okay. Here, use synthetic division. Again, you want to make sure that you write the terms in descending order. Notice here that they're not in descending order, right? This is 2x squared minus 12x, and this is minus 6x to the third plus x to the fourth. The x to the fourth ought to be first, x to the third ought to be second, the x squared ought to be third, then the 12x. So let's see. So we're going to write, and then, you know, this term, even the 6 plus x is out of order. It should be x plus 6. But remember, for this one, this is going to be x equal to negative 6 for synthetic division, right? So I'm going to put the negative 6 here, the 2, the negative 12. I'm sorry, I got to write this in order. So this is x to the fourth minus 6x to the third plus, that's a 2x squared, that's the next one, 2x squared minus 12x. So that's the order that we need to have it in. Whether it's synthetic or long division, we have to write those terms in descending order. So now just look at the coefficients. 1, negative 6, 2, negative 12. Remember, this polynomial here doesn't have a constant at the end, so that'll be a hiccup for us, but I'll show you as we work it out. So this is a 1, negative 6, 2, negative 12. All right. Always bring down the 1. Multiply negative 6 times 1, negative 6. Add them up, we get negative 12. Multiply the negative 6 times the negative 12. That gives us positive, is it 74? 72. Add the 2 plus the 72, we get 74. Multiply the negative 6 times the 74. Hey, brought my calculator from the 7th grade. Can't believe I still have it. Hopefully it still works.
Put it by the window to get to
Yeah. The calculator is like us. We need sunlight. All right. So I get, this is negative 444. So then I add negative 12 plus a negative 444. I get negative 456. But I have to keep on going because remember that last term was negative 12x. There wasn't a constant. There wasn't a constant term on that end. So basically, it's like a 0 over there at the end. So I have to keep on working on this one. So here, this guy is, and you think about up here, this is a 0 plus a 0, right? So negative 6 times negative 456. $2,736, right? And then 0 plus that term would be 2,736. That's the remainder. Now what stumped us is dang on 0 that I had to insert even at the end because it wasn't there, missing 0. So let's see how we write that. Now check this out. The initial polynomial was x to the 4th, right? So the answer drops down 1 degree less. So this is n minus 1. This is 3. So this becomes 1 times x to the 3rd. That's the 3 that I'm talking about there. Minus 12x squared plus 74x minus 456. If I could only read. Okay. And then plus 2736 over the 6 plus x, or x plus 6. I'm going to write it as x plus 6. The degree of the result is always one degree less than the original polynomial. The original polynomial, the degree was n equal to 4, right? This guy is n equal to 3 for the result. Yep.
So if you use synthetic division, you're always going to have a remainder.
For any of them, you're going to have a remainder. That remainder could be 0, right? Yep. So a remainder 0 is still a remainder. So. So this one is different from the other one, but let's move on. I want to show you this one. Here we're dividing by synthetic division, but it's missing some terms. What terms are missing?
4, 2, and just x. And 1.
Which ones again?
4, 2, and 1.
Okay, x to the 4th, and x to the 2nd, and x to the 1st. Good job, good job. So you're exactly right. So this guy is looking like x to the 5th plus 0x to the 4th plus that 9x to the 3rd plus 0x squared plus 0x minus 10. And this guy is divided by x minus 1. A lot of missing zeros, huh? Yep. That'll keep you running. So here we're going to have, from this guy, x equal to 1. So we have the 1 here. Now I'm going to list the coefficients from this polynomial. That's a 1, 0, 9, 0, 0, negative 10. Isn't that a daisy? Always bring down the first term, bring down the 1 here. So 1 times 1 is 1, 0 plus 1 is 1. 1 times 1 is 1, 9 plus 1, 10. 1 times 10 is 10, 0 plus 10 is 10. 1 times 10 is 10, 0 plus 10 is 10. 1 times 10 is 10, minus 10 plus 10, 0 remainder. So since we started with x to the fifth, the result has to be x to the fourth. So this implies that we have 1 times x to the fourth plus 1 times x to the third plus 10 times x squared plus 10x plus 10, and the remainder is 0. Yes, sir?
Will these problems get any more complicated than this? Or will they pretty much stay like this?
In terms of what you're going to experience in my math lab,
Yeah.
these are the same problems. These are your homework problems. Every problem that I do is right from my math lab. Has anybody noticed that? Yeah,
So
I'm sorry.
Any problem we get like this can be worked either way. There's not really any that's better or worse.
Right.
They can both be worked exactly.
Can we work the same either way? But again, like on the test, it'll say work it this way, and you can do that. But if I were you, I work it the other way just to check, just to make sure. Yeah. Yes, sir. And Michael, you have another question, buddy?
No, sir. I'm
Okay. Man, you are on fire today. That's good. I love the questions, man.
I've noticed they're not 100% the same, but they're close enough. Like you can still you'll have like a problem like this one, and you can go back to your notes and refer to how you work out and whatnot.
Yeah.
But it's just enough different so you having to actually work out a new problem.
Oh, you got to work it out. Yeah, I mean, when I say the same, I mean, they'll change the numbers up. And I mean, that's just, the algorithm. It has to be. That forces you to go and still do it, but you have a model from what, we're doing that you can kind of go on. Yeah, but all the problems that I've selected here in class from day one, they come directly from your homework. Okay, so as Roger from What's Happening. But anyway. All right, so the remainder theorem, use synthetic division and the remainder theorem to find the indicated function value. Here's the cool thing about this remainder theorem. Here's all it's saying. What it's saying is that if you ever want to find the result of a function value, like if you got x equal to something and you want to plug that x value into the function, they're saying you can do that by just using synthetic division. I thought that's pretty cool. So basically, in a nutshell, that's what they're saying. Now, math, they get all complicated by saying it's this and that. Like, what are you really saying so I can go to Wendy's and get me a sandwich, So,
Just trying to confuse you.
exactly. So all we're doing here is, you remember from synthetic division, the term here that we're going to put in is the 1. So 1 here, we're going to list these values from the process from synthetic division, going from left to right. Make sure they're in descending order: 4, -11, 4, and -2. Bring down the 4. 1 times the 4 is 4. Minus 11 plus 4, -7. 1 times -7 is -7. 4 minus 7, -3. 1 times -3, -3. We add these two, we get -5. So basically all they're saying is that f of 1 is equal to -5. Again, you can check that by just plugging in 1. It's just a check. F of 1 is equal to 4 minus 11 plus 4 minus 2. Something there is not right. Oh, we're good. This is 8, and that becomes 6. So minus 11 plus 6 is -5. I was canceling out the 4s, but they're both positive 4s. Okay. I was about to leave and go cut grass. There was a math teacher. He's the lawn man now. He can't do math anyway. No. Okay, so. Oh boy. So let me go back. And there was one that I didn't do. It was this guy right here. All right. So I think that's the one. Yes, that's the one. It looks very similar to this one, but the numbers are a little bit different. I need you to work this guy, and then when you get through working, I'll flip the page and see if you get the answer, okay? So, for those who are able, the retake for test 2 after class today, and then don't forget on Tuesday, we'll do test number 3 here in class, okay?